All right, today we're taking a deep dive into the very architecture of the mind. We're going to look at the classic blueprints for how we think, and then we're going to push right to the edge, to the really radical, mind-bending ideas about consciousness itself. And our whole journey really starts with just one single question.
So this is the big one. Pretty much everything we're about to talk about orbits this single massive question. How do you get animate beings from inanimate matter? How can a mind, a thinking, feeling you, emerge from what is essentially just mindless stuff? It's the central mystery that keeps the entire field of cognitive science going.
You know, to even begin to tackle a question that big, you need a special kind of science. People sometimes call it the decathlon of the mind, because no single field has the answer. It's really an all-hands-on-deck effort to piece together the most complicated puzzle there is.
And this is what we mean. This is the so-called interdisciplinary hexagon, and it makes a really important point. No one has the whole story. Philosophy is asking, what even is consciousness? Neuroscience is looking at the physical brain, the wetware. AI is trying to build a mind from scratch. We can only really get the full picture by connecting all of these dots.
Okay, so our first major theory comes from the brilliant Douglas Hofstadter. He came along with this pretty radical idea. He looked at the mind and he didn't see a messy biological organ. He saw an elegant, formal system, almost like code.
At the absolute heart of his theory is this beautiful concept called the strange loop. So imagine you're moving up through the levels of a system, say from individual neurons to networks of neurons to thoughts. But then, when you get to the very top, you find that the highest level suddenly loops all the way back down to affect the lowest level. For Hofstadter, this self-referential feedback loop is the magic trick. It's where the sense of I just pops into existence. And this isn't just some philosophical hand-waving. It has a perfect parallel in pure mathematics. The mathematician Kurt Gödel proved that any formal system, if it's complex enough, can create statements that refer to their own unprovability. The system essentially becomes aware of its own limits, a perfect logical strange loop.
If the math is a bit much, just think of the artist M.C. Escher. You know his work, right? The hands that are drawing each other into existence, or the staircases that go up and up and up forever, only to end up exactly where they started? Those are strange loops. He gave us the perfect visual for a system that contains and creates itself.
And you can even hear it. J.S. Bach did the same thing, but with music. In his incredible canons, a musical theme will twist and turn through different keys, only to arrive seamlessly back at the beginning, ready to harmonize with itself. So you've got Gödel, Escher, Bach, three different geniuses, all pointing to the same profound idea about self-reference.
Okay, that's a beautiful, elegant picture, but what if the mind isn't a pristine logical system? What if it's a messy, biological tool built for one purpose and one purpose only, survival? Well, this brings us to a really powerful, modern challenger.
So here's where we see a major split. On one side, you have Hofstadter, who argues that intelligence is kind of like software. It doesn't really matter if it's running on brain cells or silicon chips. But on the other side, you have the philosopher Andy Clark, who says no way. For him, intelligence is fundamentally biological. It's a piece of meat that predicts, just to keep an organism from, dying.
And this is the core of his theory, which is called predictive processing. The big idea here is that your brain isn't just sitting back, passively waiting for information to come in from your eyes and ears. No, it's an active prediction engine, constantly generating a full-blown simulation of the world, trying to guess what it's going to see, hear, and feel next.
Clark has a great name for this, surfing uncertainty. And it basically works in a three-step loop. First, your brain predicts. Second, it compares that prediction to what's actually happening and flags any mismatch as a prediction error. And third, and this is the really cool part, it has two options. It can either update its internal model of the world, or it can act on the world to make reality match its prediction. This is why perception and action are totally inseparable.
And this all leads to a pretty stunning conclusion. What you experience as objective reality, it's really just your brain's best guess. It's a controlled hallucination, constantly being checked and corrected by your senses. You don't just perceive the world, you actively predict it.
So, we've had the mind as code and the mind as a prediction engine. But now we're going to the real bleeding edge of science, to a theory that suggests consciousness isn't a pattern or a process at all, but a fundamental property of physics itself.
So, meet the general resonance theory. The core idea is surprisingly simple. Consciousness is resonance. You know how if you pluck one guitar string, another one tuned to the same frequency will start vibrating too?
This theory suggests consciousness is like that. It's what emerges when things from neurons all the way down to atoms start vibrating in sync.
The theory is built on 4 big ideas. 1, everything vibrates. 2, it embraces a concept called panpsychism, the idea that all matter has some basic, primitive form of experience. 3, things vibrating near each other will tend to sync up. And finally, number 4, this shared resonance is the mechanism that combines all those tiny, simple bits of experience into a big, complex, unified consciousness like ours.
Now, is this accepted science? Oh, not yet. The debate is pretty fierce. On the one hand, supporters say it offers a physical, measurable way to explain how our brain takes billions of inputs and creates one seamless experience. But critics fire back that, hey, just because things are in sync doesn't mean one causes the other. And a lot of scientists are very skeptical of that panpsychism idea, saying it's just not scientific.
But here's the thing. Whether the mind is a loop, a prediction, or a vibration, these theories aren't just abstract ideas anymore. They are directly inspiring the kind of technology that is changing what it means to be human, right now.
I mean, just take a look in recent breakthroughs in brain-computer interfaces. We've now got a system that can decode a person's inner speech, their thoughts, from a vocabulary of 125,000 words. That's incredible, and it really supports that idea from predictive processing, that thought and action are deeply, deeply linked.
And the connection is getting even more intimate. Researchers have created artificial neurons that don't just listen to the brain, they can actually talk back, responding to biological signals in real time. We're moving from a simple interface to a true symbiosis, creating genuinely hybrid systems.
All of this research is pushing us towards a completely new kind of computation. People are calling it right-brain computing. The idea is to move away from the rigid, step-by-step logic of current computers and instead build hardware that thinks more like brain, using parallel, resonant waves of light to solve huge problems in a totally different and way more efficient way.
Which brings us right back around to that most radical idea. From strange loops in code, to prediction engines in our skulls, to the very physics of vibration, each model gives us a new lens to see ourselves. And if that resonance theory has even a tiny bit of truth to it, it leaves us with a really profound final thought. If consciousness is just what happens when things vibrate in sync, what else, out there in the vastness of the cosmos, is humming along with us?